So welcome to Physics Clinic again. So in continuation with the topic, we are now going to discuss about electron orbits. The Rutherford nuclear model of the atom, which involves classical concepts. First of all, you know about classical concepts and the quantum concepts. Okay? So before Einstein and after Einstein, we can say. Even Einstein also believed all the Newton's theory. Initially, his startup is coming from Einstein only, Newton only. Okay, Newton theory or corpuscular theory we used to say, that is classical. Corpuscular means every particles, we consider the matter is only a small subatomic particles, all are particles, basic elementary particles, protons, neutrons, everything as a particle, corpuscles, he used that word, corpuscles, right? They didn't understand the wave nature of a particle. So initially, the classical mechanics does not support, or classical physics does not support any wave nature. Okay. So after the invention of, Max Planck plays a very vital role. Okay, he associated with Einstein, and then he suggested that each and every particle we didn't consider. For example, we didn't consider one proton from it, one electron from it. We had to take a mass, a group of atoms. Or we have to consider a packet of atoms or an amount of atoms. So that is said to be a quantum. What is a quantum? Some amount of atom. Okay. So he considered like that. So he considered only energy as heightened to nu. What is nu? Last lesson we saw. Frequency. Okay, he considered like that. The atomic radiation will be emitted. So he conformed with the Huygens principle. Huygens was the first. Okay, he just derived all those wave theory. Okay, light is emitting, light particle is there. If there is a light particle, it suffers reflection and refraction. Okay, but also it produces interference pattern. Also it is diffracting or diffracting. So based on that, it behaves like a wave also. So that light is a wave is a very big theory proposed by Huygens. So following on everyone, so he proposed what? Who? Max Planck. He just suggested, Einstein discussed with E is equal to mass into c squared. Right, c is the velocity of a light, because we see only the visible region of an electromagnetic radiation. But Max Planck is converting everything into a quantum nature. So he considered E is equal to h nu. This is a quantum. Okay. So E is equal to h nu deals about nu means frequency. Frequency means he is conforming everything as a wave. Get my point?
Yes.
So this idea we are moving into this Rutherford nuclear model of the atom, which involves classical concepts, pictures the atom as an electrically neutral sphere.
So stay in the call or leave?
Yeah, just leave. Leave from that meeting. Okay. So electrically neutral sphere. What is electrically neutral sphere? What is the meaning of that, ma? Atom is said to be electrically neutral, right? Why it is?
Protons and neutrons.
Right. Number of protons is equal to number of electrons. Right. Both are neutral. Both are equal in number. So that atom is neutral.
Yes.
So then consisting of a very small massive positively charged nucleus at the center, surrounded by the revolving electrons in their respective dynamically stable orbits. So what a very good definition for an atom. This is a good definition of an atom. Right? Initially. So that, as you have asked, right, Rutherford atom model is classically true.
Yes.
Get my point? So, the electrostatic force, from this only the question was discussed. Okay? So, the electrostatic force of attraction Fe between the revolving electrons and the nucleus provides a requisite centripetal force. Since it is revolving around the nucleus, the force may act towards the center. So, that is centripetal force.
Yes.
Right? Then, this is electrostatic force of attraction, then there is centripetal force. So, both should be comparatively equal. Right? See, for example, what they try to say, electron orbits. If it is a nucleus, this is an orbit of an electron. Now electron is moving. Here the electron will be, it is revolving around the nucleus. So it may experiences here positive charge, here negative charge. It may experiences force of attraction, nuclear force of attraction.
Yes, ma'am.
And then this nuclear force of attraction is experiencing from where to where? Mainly,
Nucleus to electron.
yeah. Say for example, why it is nucleus to electron? Why it is nucleus to electron we are considering?
Electrons revolve around nucleus.
No, ma. We are considering one electron. Electron mass is very, very less. Nearly 2000 times lesser. 1837 times lesser than the mass of a proton. Understood or not?
Yes, ma'am.
So basically the mass of a proton is high. So that influences the electron.
Okay.
Okay. So how the force of attraction will be? Electrostatic force of attraction will be outside. Is it clear for you?
Attraction is
Outside. It tends attract.
okay.
It is providing nucleus force of attraction. It is
Yes.
extended. In such a way also you can say. You can just write in such a way, or you can just write the electron is attracting towards. Okay? So anyways, it is influencing an electron. So this is electrostatic force of attraction.
Yes.
Okay? Since the electron is moving, right, like this, what is the velocity of an electron? Like this it will be. So angular momentum is mvr. It suffers angular momentum. Bohr's postulates it confirm. mvr is the angular momentum, that is nh by 2 pi. mvr is equal to nh by 2 pi. This is the integral multiple of h by 2 by everything we have discussed. What is this? It is linear momentum, right? Sorry, angular momentum.
The MB square by R.
mvr. Angular
Yes.
momentum. Okay?
Okay.
I'm not talking about centripetal force. Angular
Angular
momentum.
momentum.
Bohr's postulate, second postulate.
Okay. With dual radiation.
No, you have discussed in class 11 atomic structure also.
Okay.
So it is Bohr's postulate, mvr is equal to nh by 2 pi.
Okay.
So first n is equal to 1, 2, 3, etc. So what is it actually? It is revolving around in a circular orbit, so that this 2 pi comes.
Yes.
Okay. So everything it clearly shows from the Bohr's postulate. Based on that, they are saying it is revolving with what velocity? Angular velocity. Always angular velocity is designated by letter L.
Yes.
So and then due to this, there is a pull towards the center. Due to this, there is a pull towards the center. That forces the centripetal force. Understood?
Yes.
So these two forces have to be balanced. Unless otherwise the electron doesn't move in a stationary orbit. So we are talking about the stationary orbit. The electron is not doing any zigzag. Once it is moving in this orbit, again it is not moving in another orbit. Like it is not moving in another orbit. It won't switch over. Is it a path over there? It's an imaginary line we are drawing.
Yes.
Okay. So once suppose if there is an electron here, it will take away the uniform orbit. It is revolving around the nucleus uniformly. Constant orbit is there. How it is maintaining constant orbit? Like our cycle wheel. You are pedaling. Okay, how the cycle wheel is balanced? Suppose if you stop a cycle wheel, okay, if you stop a cycle and then without stand, will the cycle be stable?
No.
But while moving it is stable. Why?
Centripetal.
Centripetal force is balancing the centrifugal force. Centrifugal force we used to say the frictional force, outward force. Here, the outward force is force of attraction, electrostatic force of attraction.
Yes.
It is balanced with
Centripetal force.
Understood?
Yes, ma'am.
So that it may remain in the stationary orbit.
Okay.
Clear or not?
Yes, ma'am.
Okay. Unless otherwise it won't traces its path. Sometimes it might be here, sometimes it might be here,
Okay.
sometimes it might be here. These two electrons. Okay?
Yes, ma'am.
So this is very important. So it has to be balanced, right or not? What is Fe is equal to Fc? We know that Mv square by R is the centripetal force.
Yes, ma'am.
And then what is Fe? What is Fe, ma?
Coulombic force between proton and
Proton and electron. Very good. So proton is, so 1 by 4 pi epsilon naught. What is the charge of a proton? N. One proton we are considering, one electron we are considering. So E times E. Clear?
Not minus solvents.
Other actually we are not considering. So both are based on Newton's third law of motion it is obeying.
Okay.
Okay. For every action there is an equal and opposite reaction. Like that. Is it clear? So from this calculate R now. Calculate R. One R gets cancelled.
Yes.
So keep this R to the right side. Bring this mv square to the left side. So it will be getting this. So we know that kinetic energy and electrostatic potential energy of the electron in hydrogen atom are. We are considering hydrogen atom. Since hydrogen atom contains one proton or one electron. So what is the kinetic energy? This is the formula. Half m v square. So they are getting here v square. What is v square here? So if you just bring this v square and r, just exchange it. V square and r. Do exchange it. V square is equal to E by 4 pi epsilon naught m r. Clear? Clear? So this is V square. What is kinetic energy? Kinetic energy is equal to half m. You just replace this V square. So m and m gets cancelled. So E by 8 pi epsilon naught into r. Clear?
Yes, ma'am.
What is the potential energy, ma'am? What is potential energy? What is potential energy? How this relation comes? You have studied in first lesson.
Minus mv.
You have studied in first lesson. What is the potential energy? First you have learned potential.
Yes, ma'am.
Okay, for the charges. You have learned, right?
kV by s.
Potential, then potential difference, then potential energy.
Yes, ma'am.
What is potential energy? This is the formula, right?
Yes.
Q square by 4 pi epsilon naught R. What is potential? Everything forgotten.
Ma'am, ma'am.
Huh? So all of you, what is potential? What is potential?
Ma'am, kV.
Work and
Yes, ma'am.
energy.
kV square by r.
kV square by R எடுத்துக்கலாம். அதுல இருந்து full derivation க்கு அப்புறம் நீங்க என்ன பண்ணிருக்கீங்க?
மேம் புரியுது மேம் அதுதான் அப்படி
Why it is negative? Work done is against, right? Work done in moving unit positive charge.
against the
So,
source.
yeah,
Yes.
so that the negative sign comes.
Okay.
So here you have children, you have to write in your book. Here it represents C chapter 2. Let me know the page number. So if you have book with you, just make a note of the page number of this particular relation. Then while learning this lesson, you can go through that particular lesson also. Parallelly, you can learn both of it. Clear?
Yes.
That's my point. Take a note of this, unless otherwise you'll be blinking while writing the derivation. So So by learning like this, the derivation is very simple. What is this K plus U right now? This is the total energy, right? For a hydrogen atom only we are speaking one electron and one proton is there. So we are taking only hydrogen atom. So what it is here? Hello, they are adding. You can able to add, right?
Yes.
So the result will be here. So the total energy of the electron is negative. So this implies the fact that the electron is bound to the nucleus. E were positive, an electron will not follow closed orbit around the nucleus. What is that? If E is positive, then what will happen? An electron will not follow closed orbit around the nucleus. How? Why? If E is not negative. Why the total energy of the electron is negative? They are given the reason the electron is bound to the nucleus. Okay?
Yes.
If E is this total energy, if the total energy is negative, then it is bound to the nucleus. That's what we have learned already. This energy needs total energy. If you are bringing close together, the work should be done against it because it is approaching to that nucleus.
Yes.
It has its limit, right? It is bound to the nucleus. The electron is. Unless otherwise it might be deviated from it. If it is positive, the energy is very high. So that the electron may deviate from it. Or it does not follow closed orbit around the nucleus. Okay, ma? So make a note of this point. Then we'll move on to the next. Atomic spectra. This and all you have learned from your class level. Or electromagnetic waves also I have explained you fully. Right? So this is nothing but what it is actually. What is happening? I'll explain you again. So how the electromagnetic, the last class also, last lesson also I have explained. You didn't go through that. Okay. So this is actually how the atomic spectra we can learn. There is a ground state, energy. So what is the ground state of an atom? So I am literally bored to take all again and again. So what is ground state? The atom which is having its own orbits. For example, suppose if you are considering any one atom, for example gold atom. Okay, if the outermost electron stays in its own orbit, then it is said to be ground state. If the outermost electron absorbs energy, it moves to the higher level.
Yes.
From the outer source, right? If it moves to the higher level, the excited level will be E1, for example. This shows just an energy level. Okay, if an atom moves to the energy level, excited level, then it can't stay in it for a longer hours. It's a very short period.
Yes.
So it again comes to move to its original state. That's what they are saying, elastic limit of that particular atom. Okay, it regains its original ground state.
Yes.
Understood? Then what will happen? When it comes back to its ground state, definitely it has to lose electron. Or it has to lose energy. Okay, that last energy is in the form of electromagnetic wave. Since the electron is responsible for both electric field and magnetic wave, everything I have explained you already.
Yes.
So electromagnetic wave is a radiation which is responsible here, which is the result here when the excited electron tends back to its ground state. Is it clear or not?
The last one will repeat it.
So what is happening here? It is not, in the excited level for a longer hours. It coming back to its original state.
Yes.
If it comes back to its original state, then what will happen? Definitely it has to lose energy. But all the energy gained by it should be lost by it. Okay?
Yes.
If it loses energy, that last energy is in the form of radiation which is coming out
Okay.
from an atom. So that we used to call that as atomic radiation.
Yes.
So atomic radiation, if you view through some spectrometer, so there are so many spectrometers, we used to call that radiation as spectrum. The spectrometer is used to measure the spectrum. Okay?
Yes.
Understood or not? spectrum is nothing but like an electromagnetic wave. Maximum. Okay? For a hydrogen atom, this is said to be the spectrum of the hydrogen atom. Line spectrum, it is known as. There are different spectrum available. We can see through the spectrometer. Okay? So initially the portion was, you will be having spectrometer also in this portion. Okay, right now it is reduced.
Yes.
So line spectrum, then continuous spectrum, then band spectrum. These are all the types of spectrum you may receive from different types of atoms. So this is a hydrogen spectrum. This is all you have learned, right? Lyman series, Baumol series, Pascal fun. Okay?
Yes.
Class 11 chapter. There are absorption spectrum and emission spectrum. See, what is it absorption spectrum they are saying? I've discussed about, I was teaching, what is this? This is ground level, E1. So, what does it represents? The outermost electron is now in its ground state.
Yes.
If the electrons absorbs energy, it is also absorbing energy from an outsource, right? It is absorbing energy from an outsource. What is the meaning of outsource? From the light or emitted from sunlight also.
Yes.
Okay. How much energy is absorbed by this outermost electron can also be viewed by a spectrometer. Then that spectrum is known as absorbed spectrum. This is known as absorbed spectrum. Okay?
Yes.
Then it moves on to the higher energy level. Then it returning back, right? Okay? So it releases energy or electromagnetic radiation. It is known as emission spectrum. Understood?
Yes.
Okay, that is explained here. What is meant by white light? Combination of all wavelengths. Sunlight is a very good source. Okay? Understood?
Yes.
So through a gas, which here they have considered hydrogen gas. I told you, no, emission line spectrum of the gas is observed. So then Bohr's model of the hydrogen atom is discussed here. See, this is an accelerated atomic electron, spiraling electron, recoiling of electron. Okay? If electron loses its energy, definitely it might be just fall into the nucleus. Fell into the nucleus, definitely.
Yes.
Okay? This theory I have explained in some other video. Okay, as very good explanations I have given. So why the recoiling of electron takes place? Can an electron can jump into a nucleus. Okay? So that is I have explained in that. I just attached with that description box. I will specify that video link in the description box. Okay? This is also these theories I have explained you already. And then you will be asked a problem like this, right? What is this actually? What is asked? According to classical electromagnetic theory, calculate the initial frequency of the light emitted by the electron revolving around a proton in hydrogen atom. What is given here? Initial frequency of the light is asked. Okay? Emitted by the electron.
Yes.
Revolving around a proton in hydrogen atom.
So, Kayla, what are you doing, ma?
I'm doing math.
Anita.
Is it clear?
Yes.
What is it? Explain.
And angular frequency in the formula.
What does it represents? This V represents. What is that V represents?
Angular velocity.
Velocity.
Ah,
This represents.
velocity.
Okay. What does it represent? Because in your book, these two V you don't confuse. Understood or not?
Yes, ma'am.
What is this V? What is this V and this one?
On
What is this?
the frequency, ma'am.
Frequency.
Or velocity.
What is the relation?
Angular velocity.
No. Very easy relation.
The velocity equals to omega.
Hmm? What is the velocity? Distance by time. Okay, what is 1 by time?
Frequency.
Frequency. Well, if you take down this, so it will be 1 by time is going to be frequency.
Yes, ma'am.
So what is the letter denoting velocity? You can write capital letter for velocity. Okay, if you follow this, then it will be quite a bit confusing in your book. Distance. Distance. What is the distance? Actually, it is the orbital velocity, right?
Yes, ma'am.
So it is moving around the circumference of the circle. So it will be 2 pi r. The distance will be 2 pi r. So the frequency can be denoted by letter nu. It is actually mu. If you want to find in frequency, then mu is equal to v by 2 pi r. So they will be getting the formula from this.
Yes, ma'am.
Have you copied down? Copied or not? Then all means, post, postulates are discussed. This is all very easy postulates already we have discussed. What all I have told you initially that's given here. I've already taught you like what is the angular momentum. Integral multiple of h by 2 pi. Right? And then I told like it is E1 and E2. Here it is given E initial minus E final. That's all. Understood or not? E initial is the ground state. E final is the excited state.
Yes, ma'am.
Okay? So the difference in energy is now radiating.
The frequency, ma'am. Energy.
Wait, that is radiating as an electromagnetic wave, right? It is electromagnetic wave energy. E is equal to h. Planck's
Energy lost.
Planck's formula.
The
The energy lost by an excited atom.
Yes, ma'am.
Excited atom. Is it clear? Then the radius of the nth possible orbit thus formed is by means of the quantization condition. They will be getting this. Okay? So what they did here? From the initial one, you have find radius of the electron orbit, right?
NH by 2 pi to rotate.
It is nothing but it is actually the electron is orbiting around the nucleus, right?
Yes, ma'am.
If it is orbiting around the nucleus, it may experience angular velocity. Okay?
Yes, ma'am.
But it covers the distance 2 pi. The angular distance, angle will be 2 pi. Okay? So 2 pi is the angle. Okay, what is h? H is actually Planck's constant. Generally, literally, it is Planck's constant. He performed experiment, and then from that experimental observations, he found the value of Planck's constant as 6.6 times 10 power minus 34 joule second. So you will be given this value as a hint. Don't worry.
Yes.
Okay. So he suggested like this h by 2 pi. So why it is integral multiple of h by 2 pi? This n comprises first orbit n is equal to 1, second orbit n is equal to 2, third orbit n is equal to 3, like that. Clear?
Yes, ma'am.
Then this energy and radiation we have already learnt already, right? This is generally it is denoting nth orbit. We have learnt for hydrogen atom initially, right?
Yes, ma'am.
So they have substituted all the values here and find out the remaining. So what is the mass of an electron? Mass of an electron is 9.1 into 10 to the power of minus 31 kilogram. Like the way mass of a proton and everything you have to substitute it, and then E is 1.6 times 10 power minus 19. Then H value. Okay, epsilon naught value. Everything you know, right?
Yes, ma'am.
So all the values are substituted and then the result will be like this. Okay. If if you are converting electron volt into joules and joules into electron volt, this is the major conversion, right? This you know, right?
Yes, ma'am.
Already we have learned. 1 electron volt is equal to 1.6 times 10 power minus 19 joules. So if you convert this into, then it will be negative 13.6 by n square electron volt. This is in the form of joule, this is in the form of electron volt. Understood?
Yes, ma'am.
Then this energy level also I have explained here. Just go through all the theory, everything I have explained, what is ground state, what is the excited state. Right? You better go through this. Then the spectra of the hydrogen atom, Lyman series, Balmer series. Okay? So for understanding this thing, you have to compare with your class 11 chemistry book. Okay? Suppose if an electron is have, this is very important point. Do listen. If the electron can have total energy above E is equal to 0 electron volt. In such situation, the electron is free. Thus, there is a continuous of energy states above 0 electron volt as shown in the figure. Okay? Initially, there is no transformation. I mean, EF minus EI will be 0 if it is bounded to the nucleus.
Yes.
If it is unbound to the nucleus, then definitely energy will increase, right? Like the way they are.
Okay.
Then de Broglie's explanation. So what we explained? So this also I have explained here, right? The same, he is just doing everything. And then this is a famous history, you just go through it. Okay? Like a string. So you know that the electron is revolving around the nucleus, it also spins around it. Right? If you are talking about one nucleus traces this path means the other nucleus be like this.
Yeah.
You have 2 electrons in orbital. The maximum number of electrons in each and every orbital is 2. Right? So one electron in the positive direction,
Yes, ma'am.
spin. Another electron spins in negative direction. That's what Pauli's exclusion principle says. What it says. No 2 electrons can have same identical quantum numbers except the spin.
Yes.
Right? Understood? Like the way the electron will be. The first electron like this. Okay. What is the first electron? This is first electron. Okay, it spins in the positive direction. Then negative direction, positive direction. It spins like this. Okay, this is second electron. It opposes the spin of the first electron. So that I told you already, it combines to form like a, in s orbital, it combines to form like a sphere.
Yes.
The influence of the plus of rotation and minus of rotation. Like that. We need to consider like a energy. It's an energy.
Okay.
Right? Clear?
Yes, ma'am.
Always you must see this 2 pi r. 2 pi r means it is representing the circumference of the circular orbit.
Yes.
That should be equated to 1. If it completes one rotation, one complete rotation, then it will be lambda, 1 wavelength.
Yes.
Okay? Then I have told you this also, right? The same thing they have written here. See, for example, I told you the second law, second postulate, right? MVR is equal to NH by 2 pi. This thing they have shuffled, like MVR is equal to NH by MV. For nth orbit, they have suggested Rn and Va. Clear?
Okay.
The Bose model is applicable only to hydrogenic atoms, not for bigger atoms.
Yes.
There are so many failures and drawbacks. You better go through this. Limitations are explained here. Okay, go through this. See, hydrogenic atoms are the atoms. What are hydrogenic atoms? Atoms consisting of a nucleus with positive charge. Okay, plus Zt.
Yes.
And a single electron. C is the proton number. This and all you know, right? Huh?
Yes, ma'am.
That's all about atoms. We'll move on to the nuclei. Here you must understand what is atomic mass unit. This is all you have learned, right? Why this atomic mass unit is preferable? Since there are isotopes, right? If you are considering hydrogen consists of 3 isotopes. 1h1, 1h2, 1h3. So mass will be varying. Mass number is varying. Understood?
Yes.
So based on that, you might have seen protium is present abundantly. Okay, 95% are protein. So 2.7 or 8% deuterium. Remaining percentage will be tritium. Okay. So the abundancy is taken into an account. Okay. So that how we can just group into it. Out of 100%, 95% will be protein.
Yes.
So into protium's atomic mass. Atomic mass is mass number. Then plus out of 100%, how much amount of deuterium is there? Understood or not?
Yes,
95 by 100 into 1 plus 2.57 or 8 by 100 into 2. That mass number is 2. Then 1 point something by 100 into 3. Then we have to take an average of all those things. Not an average, we just add, simplify and add. The resultant will be 1.0008. So 1.0008 will be the atomic mass unit of a hydrogen. Clear or not?
Yes, ma'am.
We did consider hydrogen as a single element because hydrogen exists in 3 forms. Abundantly we are getting protein. Okay. So like chlorine also can taken, carbon also can taken. Carbon is having carbon 12, carbon 13, carbon 14, carbon 15. So many isotopes might be exist. Okay. So what they have taken, the mass of an atom is very small compared to a kilogram. So the introduction part, radioactivity, fission and fusion, I have explained right now. What is radioactivity? Right now we are going to discuss in detail, but you must aware of all these points, right? Radioactivity, fission and fusion. Radioactive means nuclear bombardment takes place.
Yes.
Okay. So you just go through it. The mass of an atom is very small compared to a kilogram. For example, the mass of a carbon atom is 1.992647 into 10 power minus 27 kilogram. Carbon 12 atom is present abundantly. Okay. So then, okay, it is given. See, this is what you have learned already. One atomic mass unit is defined as 1/12 of the mass of the carbon atom. This is the definition.
Yes.
1/12 of the mass of the carbon atom. So mass of one carbon 12 atom divided by 12. 1/12 of the mass of one carbon atom. What is the mass of one carbon atom? 1.992647 times 10 power minus 26 kilogram is one carbon atom's mass.
Yes.
Divided by 12 will be one atomic mass unit. So it will be 1.660539 into 10 power minus 27 kilogram. Okay. For chlorine atom also it is given like that. I told you no. So chlorine 35 and chlorine 37 will be there.
Yes.
The This is all you have learned, right? This will be 75% available, this will be 25% available. Availability. So you have to write 75 by 100 times 35 plus 25 by 100 times 37. If you just add and do everything, so you will be getting 35.46 atomic mass unit. Okay? Clear or not?
Yes, ma'am.
Okay, you know about isotopes, right? So for an isotopic mass only, I've explained you right now. For an isotopic mass only, you are having atomic mass unit. Is it clear? So this is for chlorine. Exact value. Okay?
Yes, ma'am.
Clear? Is it clear for you?
Yes, ma'am.
This is for what? 1.008 atomic mass unit will be for hydrogen. Right? Because hydrogen has 3 isotopes. You know, right?
Yes, ma'am.
Okay. Go through it. Then, from hydrogen atom, we can able to calculate mass of a single electron. Very easy, right? Because it contains 1 proton and 1 electron. So we can able to, this is equal to the mass of the hydrogen atom. So mass of the hydrogen atom minus the mass of a single electron. Understood?
Yes, ma'am.
This is mass of proton they have taken. Why? How they have taken mass of a proton? How come it is possible? They said here, the nucleus of the lightest atom of hydrogen, which has a relative abundance of 99.985%. What is the meaning of that? Hydrogen is the lightest element, right? What is the mass of an atom? 99% of the mass of an atom is nuclear mass. Since hydrogen is very lighter, it has only 1 electron.
Yes, ma'am.
So hydrogen's total mass is concentrated at the center. That means we can say proton. 1 proton is contributing the mass of a hydrogen. Can we say like that?
Yes, ma'am.
So this is major mass of a proton we are seeing. First one, 1H1, that is protium, right? We used to say like that. Then, what is the remaining? If this is atomic mass unit, this is in kilogram. Okay? Then, this is equal to the mass of the hydrogen atom.
Yes.
Okay? If you just subtract the mass of a proton, then the remaining will be 0.00555. Clear?
Okay.
You are just subtracting this. This is the mass of an hydrogen atom. This is mass of a proton. You can subtract these two.
Yes, ma'am.
So 1.00783, 1.00727. So you will be having 0.0055. Right?
Yes, ma'am.
Clear or not?
Yeah.
So we can easily calculate this. So the 2 isotopes of hydrogen are, or everything I have explained to you right now, just go through this. Take a note of it. Children, you should keep everything in your mind. This is very important for you. Okay? So my job is I will explain you. Your job is highly responsible. You have to go through it, do revise, okay, and ready. Then only it will be in your mind. Don't underestimate each and every chapter. It's very easy chapter. It's very hard chapter. Not like that. You have to give equal importance to all the chapters. Okay? Clear? We know all these things, right? These are all the charges, nuclear charges we can take. Z is the atomic number. Usually we call that atomic number Z as a number of proton. We are not considering number of electron, we are considering number of proton. If you consider electron, it will be negative. Okay. So discovery of neutron, Chadwick only discovered neutron. 1932 only he discovered. Then only the very big, what we are just experiencing right now, nuclear explosion and everything. So nowadays the war is happening, right? Between Israel and other countries. So nuclear explosion, it just came into existence after the discovery of neutron. Okay. So you just go through it. This is mass of a neutron. From hydrogen, it is very easy to calculate mass of a proton, mass of a neutron, mass of an electron. Right? Just keep in your mind all these things. This you know. What is A denoting mass number?
Mass.
Z denoting atomic number. Okay. What is A minus Z?
Number of proton. J. Neutron.
Neutrons. So number of neutrons is nothing but A minus Z. We can take. Is it clear for you? How do you represent an element like this? Mass number will be at the top, atomic number at the bottom. Like this only you can able to address the element. What is AU?
Silver.
Or gold.
Gold.
It's not silver.
AG.
Yeah. So we can represent the number of neutron as A minus Z from this formula. So you can able to calculate the neutrons here. So all these are explained. What is an isobar? Isotope you have learned. What is an isobar? Isobar is?
Same mass number, different atomic number.
Very good. That's all. That is isobar.
Yes.
Okay. Hydrogen and this helium, these two are isobars. Okay.
Yes.
We used to call this as nuclides. Okay. Then what is this Hg?
Mercury.
G. Mercury. This mercury and gold, these two are isotones they are saying. What is meant by isotone?
Same number of neutrons.
Right. Same number of neutrons. Okay. But you must understand, let me repeat, what is an isotope? Atoms of same element. That's very important. If it is a hydrogen, that should be another isotope also hydrogen. So atoms of same element having
Same atomic number.
same atomic number but different mass number. What is isobar?
Same mass number but different atomic.
But you have to say like this: atoms of same element or by different elements. Okay? Having same atomic number but different mass number.
Yes.
What is an isotone? Atoms of different element having same neutron number.
Yes.
So that is isotone. So size of the nucleus is demonstrated by this experiment. Okay. So by performing the scattering experiments in which fast electrons instead of alpha particles, okay, or projectiles that bombard targets made up of various elements, the size of nucleus of various elements have been accurately measured, and then this is the size of the nuclei, radius. Okay. It has been found that a nucleus of mass number A has a radius. Okay. So R0 is nothing but this value. 1.2 into 10 to the power of minus 15 meter. Okay. So you know that 10 to the power minus 15 means Fermi meter, right? This means the volume of the nucleus which is proportional to R cube is proportional to A. Why they are saying like this? Can you able to understand, can you able to guess this line, this sentence? What it conveys? This means the volume of the nucleus which is proportional to R cube is proportional to A. Any idea? Students? Any idea? This means the volume of the nucleus which is proportional to R cube is proportional to A. Nothing in your mind.
Volume of
Okay. So, how the atom will be? How the shape of an atom?
spherical.
Very good. So, spherical. What is the volume of a spherical?
4 by 3
Sphere.
cube.
Okay. So, volume of a sphere will be
4 by 3 cube.
yeah, 4 by 3 pi r cube. Clear?
Yes.
What is r here?
Radius of the atom.
Okay. So, that r is nothing but r naught a bar 1 by 3.
No, the nucleus or radius.
If you take an r cube, then what it will be? So what is it? Cube gets cancelled. So r cube is proportional to a,
Yes.
right or not? Understood? So if you take volume, so this means the volume of the nucleus, which is proportional to R cube, is proportional to A.
Yes, ma'am.
So volume is, so here these are all constants. So volume is proportional to R cube. So R cube is proportional to A. Understood or not?
Yes, ma'am.
Okay. So until this, you just continue. I'll be catching you in the next video. Okay. Caleb.